In this video, we're going to take a look at some calculations that we will do with binomial probability distributions. So in particular, how do we find the probability of a specific number of successes? We find that using this formula. It's really ugly. So it involves factorials in multiple places, has p to the x and q to the n minus x. So the factorial stuff, this stuff right here, we can describe that as n choose x, or how many ways can we select x items, so x successes, out of n trials if we don't care about the order in which we place those successes. So we want to know how many different ways could we choose 8 successes, and that's what this part counts. Then we're going to take the probability of success and raise that to the number of successes. That's the power for that. Take the probability of failure, raised to the number of failures on n trials if there are x successes. So if we have x successes out of n, then n minus x is the number of failures, which is that right there. So n is the number of trials, x is the specific number of successes, p is the probability of success on a single trial, and q is the probability of failure on one trial. So that's the formula. We are going to use StatDisk. StatDisk is a piece of software or an online program that is associated with a book series by Triola, and that's the book series that we're using. And so we will select analysis, and then probability distributions, and then we'll choose the binomial distribution. We're going to input the values of n, p, and x, although that value of x, that is optional, and all the values will of x would be output if we don't enter this. So we'll see this on the next page in a couple of examples. So here, our first example is a company has hired 20 new employees. Exactly 5 are female. If there were approximately the same number of male and female applicants, and they all had similar credentials, would someone have evidence of gender bias? So this question, evidence of gender bias, this is asking, is 5 unusually low? So is 5 an unusually low number of females to hire, or is it not unusually low? And so what we can do is we can say we want to try to calculate the probability of 5 or fewer. And so we can identify or observe that this is a binomial distribution. The number of trials here is 20. We are going to assume that they are fair and then see, is this unusually low if they have fair hiring practices. So P will be the probability that they hire a female if they are fair. Because we have the same number of male and female applicants with the same credentials, then P is equal to 0.5. The probability that any one position would be filled by a female if they are fair, because they have the same number of male and female applicants, should be 0.5. The probability that it is filled by a male, also 0.5. So we want to know, is 5 an unusually low number of females? So we're going to go over to StatDisk. So StatDisk, we are going to choose analysis, probability distributions, and then we are dealing with a binomial distribution. Once we choose these, over on the left-hand side, we have places to input 3 different values. So the number of trials, each person that they hire is a trial, so there are 20 trials. We are assuming that they are fair by default. So if they are fair, then half of the time they will hire a female and half the time they'll hire a male. And we are looking specifically at they happen to hire 5 females. And so we will evaluate this. And when we evaluate this, it gives us some information down here. We see the mean, we see the standard deviation, and we see the variance. up here, we have, this is our value x is 5. Here in the second column, this is our P of x, so that's the probability that exactly 5 females would be hired if they were fair in their hiring practices. And so that's like a 1.5% chance, 0.015 or so. But we're not interested in exactly 5. We are actually interested in 5 or fewer because we're asking, is 5 unusually low? So that next column, 0.021 is the probability of 5 or fewer. If I rounded it to 3 decimal places, 0.021. .021 is the probability of 5 or less. Since 0.021 is less than 0.05, then 5 is unusually low. There is some evidence of bias. Let's look at another question. Nearly identical. In fact, it is identical in every way except for so we hire 20 new employees. However, now exactly 6 of them are female. And we want to know, is there evidence of gender bias? And so this question is asking, is 6 unusually low? So again, our value for n is 20. We assume that they are fair, and so we're assuming it's 50-50 because we have the same number of male and female applicants with similar credentials. And we're going to go to StatDisk again, and we are going to see, is 6 unusually low? So over here in StatDisk, I choose Analysis, Probability Distribution, and then Binomial Distribution. We're going to plug in the value of 20 and 0.5 for the value of p. I'm going to leave the value of x empty, although we would put 6 if you want, but I'm going to just show you that it will show all these values of x. So here, in this table over here, we see all these values of x, and it continues on. We're interested in the column where, or the row where our x value is 6. So way down here, that's row 7 because it started off with an x value of 0. This value is the probability that it is exactly 6. The next column over is the probability of 6 or fewer. So 0.058 if we go to 3 places. So 0.058 is the probability of 6 or less. And we observe that 0.058 is more than 0.05. So 6 is not unusually low. There is not this evidence of bias. Now let me mention that this is based simply on purely on the numbers. If this was actually a lawsuit, if someone thought that there was some bias, they would use other kinds of evidence. This kind of calculation might be used in in either case, whether they hired 5 or 6, and they would say, it's only, if they are fair in their hiring practices, this should only happen a little bit more than 5% of the time, and it happened, and so maybe this, we don't just say, this weird thing happened. We would say, maybe there's something about the way we came up with this probability was wrong. One of our assumptions was wrong. And really, the only assumption we made is that the probability they hired a female was 50%. And so if we move that down a little bit, then it makes 6 or less, that probability go up, and so that probability would have changed. All right, in the next video, we're going to look at how do we quickly calculate means and standard deviation and variance associated with binomial distributions. We'll see you there.